Project. So today I will be taking you through our Robot Worlds project based on Brownfields. So I'll be presenting on how we manage software development sources file in our Robot World project. So this project is a console-based robot world simulation that utilized the server client architecture. So we developed it using the Java and Docker, and we also managed it efficiently using the GitLab. And the tools that we used we for this project, so we use Docker to ensure the consistent environment across the development and production. So the Java was our primary programming language for developing the applications. So we manage our version control and collaboration through GitLab, which also handles our automated build, test, and deploy process using pipeline. And additionally, we also used a GitLab's wiki for documentation and issue board for our task management. Identifying the source file. So managing our source file efficiently began with identifying and organizing them correctly. So in our project, we managed to clear a directory. We managed to clear a directory structure with a descriptive file names. So the organizations of our program so helped us to keep our source file well categorized into server, clients, and other additional files. And so meeting specifications and requirements. So to ensure that our project met all the specification and requirement, we conducted a regular review and update. So we aligned our code with the project specification and promptly addressed all deviations. And also this process ensured that our project consistently met the necessary standards. So in addition, so our source file, we also manage the complementary files such as configuration files, documentation, and test script. So these files were version controlled alongside the code. So our GitLab pipeline automated the process of managing these versions, ensuring consistently and also reducing the manual efforts. Under organization procedure. So the following organizational procedure was crucial in our project. So we structured our retrieve and update procedure, and also documented everything using a GitLab wiki. So the task tracking was handled through the issue board. So we also worked in 2-week iteration, and each iteration was had a specific goals. At the end of each iteration, we showcased our progress, conducted a peer review, and we also held a retrospective to access and improve our process. So under version control, so the version control is very essential for protecting our source file. So we made a we made a frequent commits to save changes, also providing us with the capability to roll back to the previous versions if needed. So this approach ensured a detailed history of modification, enhancing a safety and integrity of our code base. And so to prevent conflicts and ensure the smooth collaboration, so we use branching and managing strategies in GitLab. Each team member worked on a separate branch, and also we conducted through a code review before merging the changes into the main branch. So this practice helped us to avoid a simultaneous updates and also ensure the high quality code integration. And under the project iteration, so our development process was organized into 2 weeks iteration. Each iteration was defined as a set of goals, and missing a goal meant that the iteration was considered to be a failure. So we showcased our process, progress to our teammates at the end of each iteration. We conducted a peer-reviewed, and we also held a retrospective to evaluate and improve our work. So this approach simulated a real world software delivery team environments. And under code base and development practice, so we worked on a version of a robot world code base from the object oriented programming module. So this familiarity allowed us to focus on enhancing our development practice and also implement the new functionality as required. So throughout this module, so we introduced the new features that we needed to integrate into the existing code base. So the sample of our code structure here is the overview of our README file. So it included the details about the server, which manages the world state and the client interaction, and also the client which allows the user to interact with the robot. So the README also covers the command that the robot can perform, and also the communication protocol between the server and the robots, and also the various game elements such as the mines, pits, and also obstacles. So here are the additional files that we have. So in conclusion, so we manage our software development files well by following procedures and also using a right tools. So our version control kept our code safe, and our structured project approach helped us to succeed in delivering a robot world project. So we're gonna move to the next section, which is section B, and thank you.
Good day. I'm Buwa Mabasa. Excuse me, I've got flu. So I'll be taking you through section B, which is code and design alignment. Is code created according to specifications? Yes, our code is created according to the specifications outlined in our curriculum. Though it was a challenge given like the code base that we had to work on, at some point we were like really tempted to change the code base, because like yeah, it was not really like easy to implement the project based on the specifications on that like code base. However, like through teamwork, like we did manage like to be able to implement those specifications in that like code as hard as it was. Um, so did we identify the methods of accessing data? Yes. We have 4 classes which have like each has a method which like is used to access the data. So on the HTTP API class, we have the get world method, which is used to access the world which is configured uh, by the user or by the end user. So we do get that world. What do we do with that world? So that world, that's the world that the user will use to play the game. So they configure the world according to the requirements and how many users will be playing that game. So the default one like is 1 by 1. However, like you can configure it to be as big as you want it to be. So we have the save world command class, which has the which has the save data method. Excuse me. We save the world which like we got using the get world method. So the data that we save there, it is the world with its dimensions, like the size of it, as well as like the pits and the mines and the obstacles inside that world. So all that data we do save it on the save data method. We also have like the restore world method, which is inside the restore world command class. That method is used to restore the world which like was saved by the user. So we use like the name of the world to restore that particular world, and this will restore the world, its size, the pits, the obstacles, and the mines inside the world. And then we have the SQLite DB creator, which is the class which has the method to create tables. So these tables are the ones that we use to save all that data, the world data, which has like the world size, which has like the obstacles, it has the mines and the pits. All that information is saved inside the table created on the create tables method. And the reason we're using the table is for like readability and for the easy access of data. The data like it's much more organized. And then the names created in the program describe the purpose of the items names. So yes, we did like name the methods based on like its function. So I did take a screenshot there. I don't know if it's really like visible enough. However, there's a create world size where like you can configure the size. As I said earlier on, if you don't want to use like the default size, which is 1 by 1, so that's the method that is used to create the world size. We also have the calculate visibility, which calculates the visibility of the robot from its current position. And then we also have the create obstacles in the world, which like already by the name itself, you can tell that like this method also like it's creating the obstacles inside the world that we already have. And then we also have create pits in the world, which like already is talking about like creation of pits inside the world, meaning like we are going to need the world to create those pits. So yes, we did try to stick to the names which like align with the functions that are being performed by those methods, as well as our classes. Our classes like are named based on the purpose that they are supposed to serve. Excuse me. And then we are moving to test strategy for the project. Um, we started with the unit testing based on the initial or the basic functionality of like the program, how we understood it at the beginning. This was uh, the easy way of doing like tests and knowing if like we are on the right track. So our tests like were based like on the like the basic things that like the program is supposed to do. Like we know that like we're supposed to have a world, we're supposed to have the clients, and this client is supposed to perform like this function. So the unit testing like we're testing those functionalities basically, and then from there we used those unit testing like to guide us further into like integrating the other methods as well for the project, and also like to create the database, and also like to do our acceptance testing, like we were guided by the unit testing. And then also as we progressed on the project, we also realized that like the testing helped us a lot with validating the functionality. So the functionality doesn't really change, however like it can be improved. So we used the test to validate the functionality, and also like to make sure that like we stick to the original specifications of what like the project is supposed to do. So that was like our testing strategy. And then compliance with user expectations and any other applicable factors. So yes, we tried to comply. We did like try to comply as best as we could, and I think we did comply. However, like there is room for improvement more, especially like with error handling. This speaks more with like the expectations of the client. When we were creating the project, like we were on the developer's mind, we're not really thinking much of the end user. So in that case, like things like error handling, I feel like we were not really incorporating them like into the program. We kind of like lost track of like how users like can make mistakes, can enter things that they were not supposed to enter, can do something like by mistake, or can try to do something and see if like they are able to do it, of which like if error handling is there, it's supposed to take care of that instead of breaking the code. So there I feel like we could have improved like the error handling in our code. We also realized that like some methods could do like with being more described. So yes, we describe the methods, we describe the classes. However, still some of them are still technical for a non-technical person. So we could have improved by like adding comments, detailed comments. Our code like it's not as commented as like yeah, we would have loved it to be more, especially for the user. We feel like we could have added more comments like for the most technical parts of the program. And then we move to the instructions to users to enable them to use our projects to their requirements. So the instructions we did like go to the README file to add all the things that like we didn't really like add on the project itself in terms of like classes, like methods, where like could have commented by like being descriptive as possible. So we did that like on the readme file. We even went as far as like attaching the screenshots of what like the user should expect there. We also like put the detailed information of like how like they're supposed to run the program. The screenshots is to help them like as to like what to expect after like running the program. For example, they're connecting like to the server as the client. What is it like that they are supposed to see as the output? So we tried like to be as descriptive as possible on our readme file to help the client to be able to use the project to their requirements. And then the showcase documentation that include a description of the program purpose. So that also is on the README file. The README file as well like has like the detailed documentation that like describe the program purpose, so that like yeah, you will be able to see it when we showcase like the project itself. So yeah, the documentation like we try to be as descriptive as possible on our README file, since like we feel on the methods themselves like we're not as descriptive as possible. But yeah, we try to use the README file to rectify that. Thank you.
Hello everyone, I'm going to be taking you through the database management system of our Brownfields project. So a database management system is a software that provides an interface for users and applications to interact with databases. It is designed to manage, define, manipulate, and control data within a database, and it provides a way to store, retrieve, and manage data efficiently and securely. So the issues that we face with data management are data redundancy and inconsistency, data integrity, data insecurity, and data backup and recovery. And the ways to solve those data management issues are to normalize and centralize control of the data, to have constraints on the integrity and have validation rules, to have access controls, encryption, and authentication to protect the data, to have backup solutions and recovery in terms of data loss and data insecurity. The common features of a commercial database management system include data storage and retrieval, where you have efficient storage and retrieval mechanisms for big data, and the use of advanced indexing techniques to speed up and make data access easier. Number two, we have data security, where we have access control mechanisms to restrict data access based on roles and permissions, and we have encryption and authorizations to protect data and verify user identities and control. And we have data integrity to support and use primary keys and following keys to ensure data accuracy and consistency. Number four, we have backup and recovery, where we have regular automatic backups to prevent data loss, and we allow the restoration of data at a specific point in time. Number five, we have scalability and performance, where we support scaling up by adding more servers. We have partitioning, where we distribute data across multiple storage locations for improved access and performance, and we have caching, where we can access frequently stored data. The different types of database management systems that we have include a hierarchical database management system, where we organize data in a tree-like structure. We have a network database management system that uses a graph to represent relationships. We have a relational database management system that organizes tables consisting of rows and columns, which is what the database management system that we are using for our Brownfields projects. And number four, we have an object-oriented DBMS, which stores data in objects similar to OOP. Number five, we have a NoSQL database management system, which is designed for unstructured and semi-structured data. The end user tools that we can use in a database management system include query tools, which consists of features such as SQL editors, which improve code readability and writing and optimizes performance and allowing us to reuse our data for future reference. We have a query builder, which allows users to create queries without writing SQL code. It simplifies the creation of data and speeds up query constructions. The limitations that we have with our query tools is that they may not be able to handle very complex queries as efficiently as when we actually write the code, and users still need to learn basic SQL to be able to use the tools. The second tool that we have is a database design tool. We have features such as a schema designer, which visualizes database structure, making it easier to design and understand relationships, and allows for the creating of diagrams for existing databases. The limitations to having schema designers is that it may be complex for users without a background in database design, and the cost may be expensive, and not all tools may support such a feature. The third tool that we have is administrative tools, which define roles and permissions controlling access to database resources. It facilitates automated and manual backups and data restoration, and provides real-time monitoring and performance tuning options. The limitations that we have with administration tools is that the performance can consume a significant amount of resources. It may require a complex setup, and effective use requires skilled database administrators. For our Brownfields project, we decided to use SQLite for our database management system, and the reason why we chose to use SQLite is because it's lightweight and easy to use. It's a serverless and self-contained database. It doesn't need a separate server process, and it does not have any complex configurations. And in terms of space, it typically uses less than 1 megabyte in size, making it suitable for environments with not so much resources. And reason number two is because it's self-contained and portable. Inte- in- it stores the entire database, including tables, indexes, and schema in a single file, which enhances portability and ease of backup. It is a cross-platform database, allowing me to move between different database systems with different operating systems. Reason number three is because it is reliable and stable. It allows for mechanisms to maintain data integrity. And the fourth reason is because of performance. It performs efficiently for different workloads from small to medium-sized applications. Reason number five is because of the accessibility and convenience. It supports a various number of programming languages, and which makes it accessible for a broader audience. And the reason number six is because it has a lot of documentation, which makes it easy to install for developers, which makes it easy to also learn and use. And it has a very active and large community, which provides support and different tools and extensions. So now I'm going to go ahead and show you our database. So this is our SQLite database creator. As you can see, we are creating a file named alldata.db, and we have code to connect to our driver, and we go on to create the different tables for our project. So we have a table for the world, we have a table for obstacles, a table for the pits, and we also have a table for the mines. So this is our SQL code. I'm going to go ahead and show you the database. So here is our database. We have world. Now we have the different types of world, which they are different sizes, the width and the height. And you have our obstacles, which store the positions of the obstacles and the world they are in. We have the mines, which also stores the positions of the mine and the world they're in. And lastly, we have the pits, which also stores their position and the world they are in. So that is our SQL-like database.
Good day once again. We're here. Now I'm presenting to you section D, which is evaluating SQL implementation and data management in web application. In our case, we are using SQLite. So in order to present that, like I'll have to run the program itself for you to see like how like we are like dealing with the implementation of the SQLite for data management. So I will stop sharing that, and then I would like to start with okay. So we have okay. So I would like to start with the README file. So as I said, this is our README file, which is much detailed as you can see. Welcome to our project. These are the types and characteristics of our robots. And then to start the server, these are the instructions, and connect to the client. We move on to the commands that you can run in the project, the communication, minus obstacles are being explained there, and the help command, the page, like what these commands do. We're giving like a descriptive, or like we're being as descriptive as possible. So looking at this, you can see that like if as the user like would go through this with this to the T, they should be able to run our project and understand what's going on. So yeah, we did try like to be as descriptive, to show the screenshots as well, what to expect when they run the server, and so forth. So yeah, that's our README file. And then now I'm going to move to the project itself. And I'm going to open the IEBJ's IntelliJ. There we go. So as I explained before, we've got classes which have methods which we use to access our data. So we have the HTTP API class, which is like the main class which sets up the web server, sorry, and handles the requests. So we use the Javelin, which is the framework to create the server, and then we have the database, which is an SQLite, as I explained already. The database that's going to store our information. And then we have the HTTP API handler there. The HTTP API handler is responsible to start and stop the server, basically. So we post like the post option, it handles the post request from the client to the server, and then it reads it, and then it reads the request body, and then it gets passed as the JSON object. And then it executes the request and send back the results back to the client. So in a nutshell, like this one, as I said on, if you remember on section B, I did explain that like it's just responsible for the communication basically. Sorry, I clicked once, but I didn't realize that like it didn't happen. So it is responsible for the communication between the client and the server basically. And then we move to the database connection setup. So we use the Java database connection to connect the SQLite, which is managed by the Drive Manager. And then we have the table creation there, which is the method that I already explained, with statements that create several tables, which is the world, obstacles, kits, and mines, right? And then each table with specific columns. The columns which have the ID, and then it also has like the X position and the Y position, and the world name. It has to be there because we have to specify on which world we're saving all this information. And then we also use primary and foreign keys to ensure data integrity and connection between the tables. So one world which has the obstacles, the pits, and the mines, all these things should be linking together to the one world. Then we have the restore and the save command. Then the save command, as I already said, like it just saves the world using like the table that we already created, and then the restore command as well does the same thing. It restores the world which we already saved. So as I explained in section B, if I recall correctly, when we save the world, we make use of the table, and then we store that data inside the table, and then we save that world using the table. Due to the complexity of like the information, as you can see, being the world, and then the world also like has its own like integers, which is the width and the height, and then now like all this has to be saved like also like within the same world, and so this is why we make use of the table. So yeah, this is our database basically, and then this is how we run it. So this is the server. We are on the server. Let me stop this. Okay, so let's configure our world. So remember when I said that like we have the default one. So the reason why I won't be using a one by one world is because in the one by one world you can't have obstacles, you can't have pits, you can't have mines, you can't have anything, even the robots, because it's too small. So let's make our world a bit bigger, which is a size 20 by 20, which is height and the width. Okay, so this is what's going to happen when we run our multi-server, as you already seen like from our review file. And then this is the server running or connected to the port 5000, and these are the commands that you can run on the server. So let's dump to see what's in our world. So yes, our world is a 20 by 20 with the area visibility to the robot like which is 5. There are no robots connected though, but yeah, if the robot gets launched and is at the center, it should be able to see 5 steps ahead of it. And then we don't have the obstacles as well, so the robots and obstacles are there. However, we do have the pits. We've got 2 pits there, and then we don't have the mines. These are randomly generated, so yeah, I didn't really have to configure this. So there are 2 pits, and there are no mines, there are no robots, and there are no obstacles. Robots are not randomly generated. The client has to connect, and then they have to choose their robot and name their robot. But for the purpose of this, like, we don't really need the robot. We just want to see if, like, we are able to save the world and to be able to restore it, right? So this is our world, basically 20 by 20 world with 2 pits in it. So I'm going to go there and run our HTTP API, which, like, is going to call, like, the XUL light DB creator to create a table. And then now, since, like, the table is created, I will go and save my world as Boa. Right. Okay, so there is Boa is saved there on that table. So you can also quit. So yeah, I can just quit. I don't have to worry, even if, like, I really love that kind of a world with 2 pits and no mines and no obstacles, since, like, it's easy to navigate around it. It doesn't have much happening there. So I saved it because, like, I like that world. So after quitting, I can go back and run our multi-server. Okay, so there is our multi-server. So let's see what's in our world. So this one, when I ran, remember, it's already on the 20 by 20. I didn't change that. Hence, you see that area visibility. But now look at the pits. There are more pits. But I don't want to have more pits. I was more comfortable with 2 pits in my world. So I can go and say, please restore Boa. So Boa, remember, is the world that I saved with only 2 pits. So I restored Boa, and then I don't want to deal with this world. So let's see if Boa is back. There is Boa with 20 by 20 with only 2 pits. So basically, this is how, like, we are making use of the database to handle our data, to save and then restore our data on a form of a table. Thank you very much. So yeah, this is the end of section D.
I'm presenting on the topic of accessing the test plan execution and the data access verification for Brownfields project. This project involves developing and testing the robot world simulation. The key part of this project is following a good plan to test the software well, and here we'll talk about how the test is carried out, following rules for execution, checking how the data is used, and finding and fixing the errors. So let's dive in. In our introduction, the Brownfields project aims to create and test a comprehensive robot world simulation. So today we'll look at how we executed our test plan, verify the database access, and identify the errors during testing. I'll cover the following key areas: the test plan execution, the use of input data, the deviation from the test plan, the following standard procedures, and the test logic part. You'll see a lot of them when I move forward on my slides. So the test plan execution. Each test in our Brownfields project follows a standard plan. a structured plan to ensure that the robot world simulation works correctly. And here are the example of acceptance testing. Not only acceptance testing, we also use this in our unit test. So now I'm gonna go to the back command test, which test the robot functionality to move backwards. And we also have the client command test, which ensures that the system handles the client disconnection properly. And there's also a dump command test, which checks the data dump functionality. And also we also have the robot the fire command test, which checks if the robot ability which this one checks the robot can fire properly, and also handles the running out of bullets. And then we also have the launch command test that ensures that the robot launches correctly, and it also handles the errors. So there's a look command test that tests the robot ability to look around. And we also have the state test that verifies the robot state constantly. So moving back to our slides, the next part is the use of data. So each test uses a specific input data to simulate different scenarios. So this ensures that the commands are executed accurately and responses are validated properly. For example, in our forward command test, we provide an input to move the robot forward for a certain distance and check if it stops at the right position. So this ensures the robot responds correctly to the movement commands and also stop correctly at the intended position. The deviation from the test plan. So sometimes tests are needed to handle unexpected conditions. Which we document as a deviations. This helps us to refine our test plan and also help us to improve testing process. For instance, in a launch robot command test, we might test what happened if the launch command is misspelled. By documenting this deviation, we can identify areas where our plan might need to be adjusted, and also ensure that our system can handle errors gracefully. So this process helps us to improve our overall test plan. The following standard and procedures. So consistency is very important in testing. By following a standard procedure, we make sure that our results are dependable and can be repeated. For example, in our back command test, we always use the same steps and same steps to connect and disconnect our robots. So this ensures that each test is performed under the same condition, providing the reliable and consistent results. So the following this standard procedure help us to maintain the integrity of our testing process and ensures our tests are repeatable. And okay, so testing logic path. So our test covers a various logic path to ensure a comprehensive coverage. So this means we test all the possible scenarios, such as the valid and invalid commands. For instance, our fire command test, we test both valid firing commands and what happens when the robot runs out of the bullet. And by testing these different scenarios, we ensure that our program handles all situation correctly and how the logic paths are thoroughly tested. Under the database verification, access verification, so I'm gonna open our, so we have our database tests. Verifying the data access is crucial to our simulation. So ensuring the efficiency and reliable data operation, this maintain our data integrity and overall functionality of the robot. So we check the data is stored and correctly, and also we ensure this smooth simulation. So I'm gonna look at the restore. So under our database test package, there's a restore and also there's a save command test. So under our restore command, our restore command test verifies the correct restoration of the world data by creating the tables for the world, obstacles, mines, and pits, and ensuring a consistency with the original data. So, and under save command test, we confirm the accurate saving of the world data by creating a similar table and ensuring the data is correctly saved and also can be retrievable. So these tests are essential in maintaining the data integrity and also ensuring that the elements are accurately restored and saved. So okay, back to our slides. So elimination of errors. So each test helps us to identify and fix errors. For example, in the state test, we check the robot state to make sure that it's consistent throughout the different operations. So if we find any situation, we resolve them to improve the software quality by identifying and fixing the errors. So we ensure that our program operates as expected and that any potential issues are addressed properly. So under the record of tests executed, we keep a detailed record of all our tests. So this provides a comprehensive overview and help us with the future references. For example, in our client quit command test, we log all the action and results to review later. So keeping a detailed record allows us to track the progress of our test and identify any errors and ensure that our tests are reproductive. So the variations and reproductivity. So identifying and resolving a variation in test result, that our tests are reproducible. So for example, in look command, we handle the different scenarios such as the valid command and misspelled ones to ensure the consistent result. So by addressing this variation, we ensure that our test produces a consistent result, and that and also any deviations are properly documented and resolved. So this helps us to maintain a reliable and consistency of our test progress. Next, we're gonna be focusing on the review and improvement. So we continuously review and improve our testing process. So this helps us to maintain a high standard of quality. So we review our inputs from the data command test to ensure that the data is accurately collected and processed. So in conclusion, for section E, the Brownfields project test plan execution highlights through testing to the standards and also the verification on functionality. So each test ensures that the software reliability and robustness, and also guiding the future development and refinements of our project. So additionally, on our database, tests ensured the accuracy of saving and restoring data, the world data. So for maintaining the integrity and consistency of our simulation. So this will be the end of section E. Thank you.
I'm going to be taking you through the documentation and design plan that we had for this project. So the documentations that we had for this project is that we had a README file, we have a wiki page, and we also used the Miro board to plan and show the overview of the project. So I'm going to go ahead and take you through our README and our wiki page. So this is our README file. As you can see, we have a brief overview of what the project is about and what it does. We have the robot types and characteristics. We have the usages for the project. We have the client and server specifications. We have the different commands for the game, and we also have all the various elements of the project. I'm gonna go ahead and go to our wiki page. And this is our wiki page, which also has a brief description of the project, the robot types and characteristics, and we also have the overview of the project, the different types of elements for the client and the server, and the commands, and we also have the project setup, which shows you how to set up the project. We show you how to clone, to CD into the project, and how to run the project. And we also have the dependencies that you need to be able to run the project. So the project was split into 4 different iterations, which all had 2 weeks each. So for iteration 1, we had to do acceptance testing, where we test how the system works as a whole. And for iteration 2, we did the CI/CD, where we built and tested real. For iteration 2, we automated the process of building and testing the project using CI/CD and GitLab. For iteration 3, we created a database to store all the players of the game and to store their current state, to store their obstacles, to store their positions and everything. And for iteration 4, we had separation of concern where we split the different parts of the project into independent elements, independent models. For iteration 4, we separated the different parts of the projects so that when you run one, when one doesn't. For iteration 4, we did separation of concerns where we separated all the different parts of the project into independent parts, so when one fails, they don't all fail. And here we have our My Report where we plan the project. As you can see, we have the project overview, we have the time that we had for the project, we have the contributors, we had all the goals that we have to achieve, having the server client interface and API, acceptance testing and pipeline, the CI/CD, and we have all the channels that we use to collaborate. We have all the requirements that we needed to satisfy for the project, both the client and the server. And yeah, that's what we did. That's what we used for the project.